Alrighty, let's do a little bell work here. I don't always do that in these videos, but I was feeling a little bell work. Let's name two congruent angles if ray BC bisects angle ABD. Now, the reason why I want to do this one is because I think we miss out on like the direction of a ray, and we get a little bit confused sometimes as to how to apply that. Alrighty, I'm going to go with plum as my color here. So BC is my ray, which would mean that it starts at B and extends on forever through C. And it is bisecting, I'm going to switch colors again. It is bisecting angle ABD, which would be this angle here. So what are the two congruent angles? Well, it'd be this one and this one. So that would be angle DBC is congruent to angle ABC. Awesome. Next, we've got M is the midpoint of AD. And if AM is equal to 12x and MD is equal to 2x plus 20, what's the length of AD? So it does say M is the midpoint. I'm going to draw a little picture so we can get a visual on this. So AD, and then M is my midpoint. Okay, so MD is 2x plus 20, and then we have AM is 12x. If it's a midpoint, then we have two congruent segments. And if the segments are congruent, they're equal in measure. So I have 12x is equal to 2x plus 20. I'm going to get 10x is equal to 20 by subtracting the 2x. And I'll get x after I divide by 10, I'll get x equals 2. That's not my final answer, though. You're going to find that a lot in this class where we solve for x, but then we have to plug back in. What's the length of AD? Well, if I plug in 2 for AM, I would get 24 here. And it would make sense that, again, I get 24 here. So 48 for my total length. Nice. Awesome. One thing you might be wondering is like, what's with all these markings that were up here? Remember, these are congruent segment markings. So this is maybe a diagram that was pulled from somewhere else. Yeah, these opposite sides over here and here, these guys are congruent. These two are congruent. Cool. But didn't really apply to that problem. Still fun to see, though. All righty, 1.8, laws of logic. We're going to be talking about the converse, inverse, contrapositive of a conditional statement. We're going to apply the chain rule, and we're going to do some kind of weird logic statements, but just go with it, okay? It's meant to get you thinking in a logical way, in a step-by-step way, all right? But it is a little weird, I'll be honest. Okie dokie. You'll see what I mean. You'll be like, yeah, that is weird. Definitely weird. All right. So, conditional statement. If P, then Q. That's our conditional statement, meaning like P would be if it's sunny out, that's P, then it's warm. That's your Q, it's warm. That's not necessarily true, but it can still be an if-then statement, right? If two segments have equal measure, the two segments have equal measure is the P, then they are congruent. They are congruent as the Q. So it's just the two parts of our statement. Negation is just putting not in front of it, okay? So not P, or you could put a little squiggle P. That is another way, like the tilde, but right in front of it, it's a negation, okay? So our initial statement is if P, then Q. Our converse is if Q, then P. We're not going to use this side over here. All right, inverse. The inverse, what we do is we just negate both. All right. So that would be not P, then not Q. All righty. Then can be written, if you haven't picked up on that, with like a double arrow like that. Okay, that's then. So you'll see a lot of symbols instead of writing out words in math. We're going to continue doing that. Contrapositive is basically a combo of both converse and inverse. We go not Q, so we reverse it and we negate it, not P. Fun fact about the contrapositive is if the conditional statement is true, the contrapositive will also hold true. All right. And we will see that in practice here in a little bit. But if I have the conditional statement, my original if then is a true statement, the contrapositive will have to hold true. Let's actually think about an example. We had one earlier. It was if we have a right angle, or if we have two right angles, then they are congruent, right? If two angles are right angles, then they are congruent. If we do the contrapositive, if two angles are not congruent, then they are not right angles. That would hold true, because if they're not congruent, they can't both be right angles, because then they would be congruent. So you can flip it and negate it, and it will hold true. And that's basically what we were just talking about. So if you want to take a sec to write that down, solid idea. Feel free to pause it if you need. All righty, we're going to skip over that. Chain rule. All righty. So if P then Q is true, and if Q then R is true, then P then R is true, meaning I can link these together as a chain of events, right? I can take that I got Q to R, and this can be expanded upon if we knew that maybe R to S and then S to T, I could conclude that P then T. I could go from the first statement of logic all the way to the last in one step, and that's by using the chain rule of logic. And we'll have another rule that's similar to that later on in honors geometry as well. But that is our chain rule. So we're going to use that here in this weird example. This is what I was talking about where it gets weird. All righty. We're just trying to think about or think in terms of logic here. So don't read too much into the weirdness. All right. If gremlins grow grapes, then elves eat earthworms. If trolls don't tell tales, then wizards weave willows. And if trolls tell tales, then elves don't eat earthworms. What can we conclude? Well, it helps to put these into if P then Q style statements. So I'm going to say for the first one, if gremlins grow grapes, then elves eat earthworms, or if G then E. If trolls don't tell tales, so not trolls, then wizards weave willows, then W. And if trolls do, in fact, tell tales, so T, then elves don't eat earthworms, not E. So what we want to try to do is link these together, okay? So I'm going to start with my G, then E. Do I have anything that starts with E? No, I don't. However, if I were to say do the contrapositive for a few of these, I'm going to do it for both. For this one, I'd have not W, then T. I flipped it and negated both. So when W comes first, I then negate it. T goes to the end, and I negate a negation, which makes it positive. And then for this one, it would be E, then not T. Well, look at that. The last one starts with E. So I can say E, then not T. And then this one right here starts with not T, then W. Look at that. We can go from G all the way to W. So if gremlins grow grapes, then wizards weave willows. You are welcome. I have just answered all of life's questions. Isn't that right? So the main thing we're getting here, guys, is that we can chain together logic statements, if-then statements, and create a conclusion going through multiple statements. And this can go on to infinity and beyond, really. All right, there's no only 3 statements or only 4. It can go very long. Cool? All right. Let's see. Actually, you know what? Why don't we do this ticket to leave here? I think that'd be helpful. So if 2 angles form a right angle, then they are acute. That's our if-then statement. So 2 angles are going to add up to 90 degrees. They're going to make a right angle. So yeah, they're both acute. So our converse of that would be flipping it. If 2 angles are acute, then they form a right angle. So if 2 angles are acute, then they form a right angle. And you might be like, well, what if they're like 30 and 20 degrees? That doesn't form a right angle. That is correct. So this is not a true statement. It is the converse of the statement, but it does not hold true. Inverse, we're going to negate both. So if 2 angles do not form a right angle, then they are not acute. That would be, I'll change color so it doesn't get too crazy all up in here. That'd be this one. Now, once again, you might be like, well, just because they don't form a right angle doesn't mean they're not acute. It could be, they could both be acute, and it wouldn't work out, right? So 2 angles do not form a right angle, then they are not acute. well, 30 and 50 don't form a right angle, but they are acute. It's not true. Again, it's the inverse. Doesn't have to be true. Doesn't have to hold true. Okay. And then lastly, the contrapositive, which would be B here. Flipped and negated. If two angles are not acute, then they do not form a right angle. That is true. If they aren't acute, they cannot add up to 90 degrees. So the pair they both have to be acute in order to do that. Well, the contrapositive is a true statement. So if the conditional is a true statement, the contrapositive also holds true. What can be concluded from the chain of logic below? Well, let's see here. I can go from A to B. So I would have A to B. And then I can use that B to not D. Okay, awesome. And then what if I were to flip this one or do the contrapositive? I could change this to not D, then C, couldn't I? Which would link up with the previous statement. So I can say A, then C. So I'm able to use that contrapositive to manipulate my statements so that I can provide a nice little conclusion there. If A, then C. All right, that's about it. You guys have a fantastic day. America, freedom, rock and roll. Costco, Riverdog Jenny on the gram. Make sure you're following Riverdog Jenny on the gram. I hope you guys have a fantastic day.